Hi there, Group 2 is here. My name is Irfan Harmi bin Harman with matrix number BC251518. So in our real life, electric field is one of the most fundamental concepts in physics because they describe how one object can exert force on one another without touching. They are the invisible forces that holds atoms together and powers most of our technology in life. In physics, electric field is responsible for metastability, while on a grand scale, electric field is responsible for some of the nature's most beautiful display. So today, our group are going to explain what is electric field, its properties, and some of real life situation that is related to the electric field itself.
Alright. So, what is electric fields? So, electric field is the area of influence of a charge. So, an electric fields to exist in the region of space around a charge of object. So, when another charged object enters in electric fields, the electric fields exerts the force on the second charged object. Alright, so the formula of electric field is E equal to F over Q, which is force over charge, or E equal to V over D, which is potential difference over distance between 2 points, according to the current context. So while the unit of the electric field is actually Newton per coulomb, or the volt per meter, and also the electric field uh, at the point is actually the vector quantity.
Now, let's look at how we calculate the electric field. The formula for the electric field is E equal to F over Q. E, electric field strength, F, electric force acting on a charge, Newton, Q is charge placed in the field, is Coulomb. So, the stronger the force is, will be a stronger electric field. The unit of electric field is Newton per coulomb or voltage over meter. The direction of the electric field is defined as the direction of force on a positive charge. This is electric field points away from the positive charge. It will be go far away because it's the same. Electric field points toward negative charges. It attract each other because it's different, right? It's positive and negative. Simply say the electric field depends on the force and charge, and the direction is always based on how positive charge would work.
Thank you very much, sir. Now let's talk about electric field line. This is electric field line, which is an imaginary line or curve, where when we draw any tangent at any point, the direction will become electric field vector at that point. The vector means that if we give a direction and also the magnitude. So electric field line of a point charge, where the electric field line will show us the direction of electric field at each point, okay, like this, like this, like this. The spacing of a field line actually will give us the general idea of the magnitude itself. Okay, we can actually calculate what is the magnitude of each of field line. So let's talk about electric field density, which equal to how closely paired electric field are, which also have indicating field strength. Okay, so we can see here this area. This area is the strongest, okay, meaning that the electric field density is at the biggest because the line, this area, okay, here, are closely paired together compared to this one. Okay, they are not closely paired together, so that's why this area, okay, has higher electric field density compared to this one.
Hello there. So we have covered the definition, the math, and the diagram for this for electric field. So I want to show you two real life application for electric field. For example, our smartphone. We can see that our smartphone uses capacitive touch screen which uses field line that we disrupt. How? Because in our body we produce bioelectric field. Okay, secondly, we also use microwave. Do you know how microwave can heat up our food? Okay, I will explain. Microwave uses the polar in our food to create heat by creating friction in the molecule. To summarize all of it, we have got to summarize the definition for force is an area which experience a force, and secondly the formula which is E equal to the force over Q, and also the electric field is negative will toward it and positive will go outward. That is all. Bye.